Okay, guys, we are into the second technique of differentiation. Now you must see that all of these expressions over here, they have got powers on the brackets here. And the powers are so big that we would not like to expand. We would not like to open these powers, okay? Even if you look at this 2 part A. So this can be written as x plus 2 raised to power minus 1. So we don't want to apply this power onto this x plus 2. So when we have a situation where expansion of power is really not feasible, then we have the second technique coming in action, okay? And the second technique tells us, let me write that second technique here and then let me cover this up to this. Okay. So I will be writing down the second technique first. It says if you have to differentiate an expression, this is just an expression over here. Don't assume that this will always be a linear expression. And there is a power onto it. So this would be n into ax plus b to the power n minus 1. This is exactly the extension of that thing when you have d by dx of x raised to power n. So this becomes n x raised to power n minus 1. But there is something extra over here. You will have to multiply this with the derivative of whatever you have inside this bracket here, that is ax plus b. So that would be this time, that would be a. So that is the derivative of the expression inside these brackets here. Okay, so without wasting time, let me take you to the examples here. Now, suppose you have this one part f, okay, and you want to differentiate this with respect to x. So we want to find this d by dx of 5 into 2x minus 1 raised to power 5. So let me put these brackets around it. So when we have to differentiate this with respect to x, so this would be 5 into 5, okay. This is going to give us 25, and then this 2x minus 1 raised to power 4, 1 subtracted from the power, and then times 2. This 2 is basically the derivative of this 2x minus 1. And if you can simplify this. So this 50 into 2x minus 1 raised to power 4. Now, just to make your belief that why does this work? Now, suppose you have y equal to 3x minus 1 whole square. Now, the square is something that we can really expand, okay? Now, first I'll be doing this with the first technique. So we'll be expanding this. When you expand this, this becomes 9x squared minus 6x plus 1. And now you find the dy by dx. You see this is going to be 18x minus 6. Remember yesterday's technique, the first technique, the derivative of 9x squared is going to be 18x. The derivative of minus 6x is going to be minus 6. And the derivative of plus 1 is going to be 0. And if you want, you can take 6 common from here. So this becomes 6 into 3x minus 1. Now let's integrate, differentiate the same expression using the technique that we are going to learn today. So this would be dy by dx, and you see this is going to be 2 into all of this, 3x minus 1, and power 1 is left here. And then the derivative of this thing, that is going to be 3. So if you simplify this, this becomes 6 into 3x minus 1. So you see these are exactly the same. But we will definitely not be going to using the first technique if suppose the power was 20 here, or if the power was 12, or if it was minus 2, something like that. So we have to learn this technique here, dealing with the expressions with the powers that we really don't fancy to expand. Okay, so now I don't like all these questions because they're all linear. So I'm going to just scroll up here. Look at this I part. Now in this I part, you have a quadratic expression inside these brackets. Okay. So if you see, this is one part I here. So let me put this equal to y. I don't like writing that d by dx again and again. So this is y equal to x squared plus 3 to the power 5. So differentiating this means finding dy by dx. So first of all, 5 into, we always have a 1 here if you don't find any coefficient here. So 5 into 1 is going to be 5. And then you have x squared plus 3. 1 subtracted from this power, that is 4. And then the derivative of x squared plus 3 is going to be 2x. So finally, this derivative is going to be 10x into x squared plus 3 raised to power 4. Similarly, if you
सर
look, yes, yes.
सर आप मुझे फिर बता सकते हैं डेरिवेटिव कैसे आता है?
Derivative is something that you get after differentiating. Like you see, this is 5 into 1. You get this 5. And then you take 1 power from this, n minus 1, that is 4. And then you differentiate whatever is inside these brackets. So what is the derivative of x squared plus 3? Derivative of x squared is 2x. And the derivative of 3 is 0. Okay, so you get this derivative 2x, that is the derivative of x squared plus 3. Look at this k part, for instance. In this k part, let me put that equal to f of x. I just keep on varying the things so that you remember what you learned in the last class. X squared plus 4x to the power 3. So when you differentiate this, guys, you must have f dash of x here, okay? The derivative of f of x is called f dash of x. So 3 into this 1 here, that will give you 3, and then you have x squared plus 4x. The power 2 is left here, and then it's a turn to differentiate whatever you had inside these brackets. So this is going to be 2x plus 4. Okay, and if you want, you can take a 2 common from here. So this will make it 6 into x square plus 4x square into x plus 2. That is the final derivative of this k part. And let me take you to these examples here, like in this question number 2. Again, I need to make you guys recall that please never ever differentiate anything which is down there in the denominator. Like for instance, if you see question number 2, part B, let's say. So you have, let me put that equal to y. So you have y equal to 3 over x minus 5. So first you need to write it as 3 into x minus 5 to the power minus 1. Okay, so you have to move that to the numerator. And beta, now you will be differentiating this. This is dy by dx, that is minus 3 into x minus 5 raised to power minus 2. And then the derivative of x minus 5 is going to be 1. So finally, this becomes minus 3 over, you can take it back, making its power positive. That is the derivative of 3 over x minus 5. Okay. Similarly, if you people look at some, let's say, look at this f part, for instance. Let me cover this area. Let's look at this f part now. Okay, in this f part, 2f, guys, you have, let me put that as f of x, that is equal to 3 over 2 into 3x plus 1 raised to power 5. So guys, we need to move this 3x plus 1 to the power 5 to the numerator. So this would become f of x, that is equal to 3 over 2 into this 3x plus 1 to the power minus 5. Now we are ready to differentiate this. So this f dash of x would be 3 over 2 into this minus 5. That is, the power is to be multiplied by this. And then 1 taken from the power. This would further become minus 6. Okay. And then the derivative of this expression which had the power. So this is 3. So if you simplify this, you have 3 into 5 is 15, into 3 is 45. This is minus 45 over 2 into 3x plus 1 to the power 6. That is its derivative, guys. Okay? Got it? Any question? Let me do that G part for you. You see that there is no power written on G. So don't worry. Let me write this as y equal to 8 over x square plus 2x. So you can always write it as 8 into x square plus 2x raised to power minus 1. Please remember, never ever try to differentiate anything which is down there in the denominator. You have to move that into the numerator, okay? So this is going to be dy by dx, that is minus 8 into x square plus 2x to the power minus 2, and then into the derivative of this thing, that is going to be 2x plus 2. So you need to be really good at the first technique so that you can differentiate using the second technique here. So I can take 2 common from here, and that 2 into minus 8 will give me minus 16. And I'm left with x plus 1 inside the brackets here. And this expression goes down there so that you can make its power positive. Okay, let me give you some more examples and you guys will be practicing it yourself. For example, look at this third question now. All these parts, they have got the power in the third form. Okay, one is its square root. There is a big chance that you might get a question on this square root wala thing in your final exam. So it's good to learn that, like, mentally. For example, if you remember, I told you yesterday that if you have to differentiate this d by dx of this under root x, it's good to do that mentally, that this is going to be 1 over 2 under root x. Do you remember this, guys? Hello? I told you yesterday that, yeah, na? Acha. Now, for the square root thing, you see, this is really handy if you learn this by heart as well. The d by dx of under root x minus 5. You can simply write it as 1 over 2 under root x minus 5 and into 1. This 1 is the derivative of x minus 5, okay? And then this is written as 1 over 2 under root x minus 5. Okay, and for instance, you look at this d part. For instance, question number 3 part d, you have, let me write it as y equal to the square root of this x cube minus 5x. So your dy by dx is simply, you need to write it as 1 over 2 into, this is x cube minus 5x, and here you write its derivative, that is 3x squared minus 5. And finally, this is 3x squared minus 5 over 2 into under root x cube minus 5x. Now, for instance, someone doesn't believe that, yaar, what is happening over here? So you can do it with all those steps. For instance, you say, okay, I am not going to learn those short steps here. So what is the power over here? It means the power over here is x cube minus 5x raised to power half. So let's use this power, and then you see this will be half into, if for instance you want to do this with full working. Now what is half? Let me write half minus 1. And then its derivative, that is 3x squared minus 5. So you will see that this is going to be half into x cube minus 5x to the power minus half into 3x squared minus 5. And if you move this down in the, denominator, this would be half into, and let me keep this 3x squared minus 5 in the numerator. And when it goes down, power half can also be written in the form of a square. So this is the same, guys. It is up to you. If you want to do that directly, no marks will be deducted. Okay, you can do that directly like this, or if you want to show all these steps, this is totally up to you. But remember, this only works for the square root with the power half, not with something like this, because if you move this to the numerator, the power will be minus half. Here the power will be minus 1 over 3. Okay, this already has a power 1 over 3. So you better do this showing all the steps. Okay, so let me do more parts, then guys it will be your turn.
चलिए ये move ना करें 1 minute.
Okay, here it is. Yeah. Okay, now let me try this 3e. Okay, let me write it as y is equal to 5 minus 2x, and this is the power 1 over 3 over here. Okay, so when you differentiate this will be 1 over 3 into 5 minus 2x, and you can do this at the side. 1 over 3 minus 1 is going to be minus 2 over 3, because rather than showing all these steps again and again, don't waste your time. Okay, and this is going to be minus 2. The derivative of 5 minus 2x is minus 2. Okay? So this is minus 2 over 3, and we move this down here. So this is 5 minus 2x raised to power 2 over 3. That is the final answer. So guys, today we are applying this technique, the d by dx of any expression. Let's say this is f of x, and there is a power n. Okay, so this would be n times this f of x to the power n minus 1 times the derivative of this f of x. It is exactly the same as saying that if you have to differentiate this d by dx of ax plus b to the power n, this is going to be n into ax plus b to the power n minus 1 times a. But when we give this rule to the students normally think that this is only going to work on the linear expressions. So this is a more general form for this second technique of differentiation. Okay, now it's time for you guys to practice these questions. Okay, let me tell you what you have to do now. These are the first 3 questions, and believe me, you have to do each and every part of this question. Okay, let me put that answers in front of you so that you can check your answers as well. So these are the 3 questions. You can
split your screen, sir.
Okay, and these are the answers. Okay, 1L may, let me write it as y equal to an x square, and let me be clever here to write it as this. Okay, because 5 over x has to be 5x to the power minus 1. So when you differentiate it, beta, first of all, this is going to be 5 into all of this, and I'll be writing it as minus 5 over x over here, okay, to the power 4. And then the derivative of this thing, the derivative of x square is 2x, and the derivative of minus 5x to the power minus 1 will be plus 5x raised to power minus 2. So we can write it as 5 into x square minus 5 over x to the power 4. And this is 2x plus 5 over x square. You can leave it at this. Okay? So I have done this to G again. You can see its solution here. And I think I conclude this session here. Inshallah, in our next session, we'll be talking about the applications of the differentiations. Okay, see you in the next segment.